Okay, welcome back. Now let's talk about sectors of circles. So what is a sector of a circle? It is just a wedge. For example, this wedge of this circle is the sector or a sector of the circle. Okay, so it's the piece of the circle that is bounded by these two radii with a central angle. So theta in this case is called the central angle. Okay, so that's another thing just to be aware for terminology. Theta is called a central angle. Okay, now the shaded in region is the sector. The line here, the purple line, the edge of the sector, of the circumference, right, or this portion of the circumference of the circle is called the arc length of the sector. Okay, so it's the part of the circumference or the part of the edge of the circle that is bounded by the two radii. Okay, and so now two formulas that you're going to want to know is the arc length. How do we find the length? Well, it's just a proportion of the circumference, right? So you can actually derive this by saying, okay, it's just whatever fraction of the circle this angle makes times the circumference of the entire circle will give you the arc length of this. Like, for example, if it was 1/4, if this theta was 1/4, if the central angle was 1/4 of the revolution of the circle, okay, then it would be this arc length would be 1/4 of the circumference of the circle. Okay, and so that's where this formula comes from. Now, this other formula is for area, which is again derived the same way. We can find the area of a circle by using the formula for the area of a circle, pi r squared. And we can say, okay, well, what proportion of the total area is this sector? Well, it goes back to taking the proportion of the angle, the central angle, with the total angle measure of a circle, right? Now, these two formulas are based on radians. Okay, so you must have radians in order to use these two formulas. Okay. So that's it. We'll leave there and then we'll do some examples. Have a great day.